Hello, statisticians. Today we are comparing graphs and z-scores. Let's get started. One of the most debated questions in sports is, who is the GOAT? By GOAT we mean G-O-A-T, the greatest of all time. In NBA basketball, the debate centers on some key players. We'll discuss three of those players today. The first is Wilt Chamberlain, whose peak era in playing was the 1960s. He's most famous for scoring 100 points in a single game, which is an all-time NBA record. Then there's Michael Jordan, who's known for leading the Chicago Bulls to a remarkable 6 championships. His peak playing era was the 1990s. And finally, there's LeBron James, who is the all-time scoring leader for the NBA. His peak playing era was the 2010s. We don't have time to do an analysis of all aspects of these athletes' careers and skills. So instead, we're going to focus on one aspect of their game, their scoring. Specifically, we're going to attempt to answer the question, who is the greatest scorer in NBA history? With that question in mind, let's move into our notes. We're going to cover two topics today, starting with comparing graphs. So the main metric we're going to look at today is PPG, points per game, looking at the average number of points each player scored per game. Over the course of their careers, both Wilt and Jordan scored 30.1 points per game. LeBron's career points per game is 27. However, we have to keep in mind that these players each played in very different eras. They played with different opponents in times of the NBA in which teams employed different strategies. They even played under different sets of rules. For example, back when Wilt played, there was no three-point line or three-point shots. So a direct comparison of their points per game doesn't really make sense to compare in context of which played when. Instead, a better way to go about this analysis might be to ask which player was best in terms of their time. We have three players, all at different times, so let's start by looking at their eras they played in. And let's use the same type of data for each era. The points per game for the 120 players in each era that scored most during those games that they played in. How does that data look from the broadest, most zoomed out perspective? This data looks at 3 eras of basketball players and how many points per game the best players scored. Next, we can look a bit closer to think about how the data looks as you begin to zoom in. We can see that the spread was biggest in the 60s. It's about the same for the 90s and the 10s, but shifted higher in the 90s. And we look at where the data falls. We see that all of the data sets are right skewed and have outliers at the top. And the top outliers are these people that we are debating about. As we continue to zoom in on the data, it would happen to see that we're seeing what is happening here. So we're going to look at box plots instead of dot plots. Here are the box plots for each era of the NBA with our outlier players labeled. The box plots identify the median for the data so we can compare the median points with each of our star players. We see the median points per game was higher in Jordan's era, about 15.5, than Wilt's era, 12.5. And when we also consider LeBron's era, we can see that the median during Jordan's era was higher then too. Going back to our original question, we can describe what we see overall. From the highest perspective, this data looks at 3 eras of basketball players and how many points per game the best players scored. Looking a little closer, the spread was biggest in the 60s and about the same for the 90s and the 10s, but shifted higher for the 90s. And all of the data sets are skewed to the right and have outliers at the top end. And finally, the median The median points per game was highest in Jordan's era, about 15.5, with both Wilt's era at 12.5 and LeBron's era at only 12. Are you starting to form an opinion about who is the GOAT yet? Well, all three are clearly among the best, but how can we measure how unusually good each player was for their era? That brings us to the topic of z-scores. Now, first we might want to compare our player to their era. So we're going to start by subtracting the mean points per game from our star players' points per game. And that will help to tell us how much better they were than average. For Wilt, we subtract his points per game from the average points per game. And we'll find that he scored 16.5 more points per game than the mean for his era. And we can do the same thing for Jordan. And we find that he scored 14.1 points per game more than average during his era. And finally, for LeBron, he scored 13.9 points per game more than average for his era. So by this metric, Wilt now takes the lead in terms of being the best scorer relative to his time. But what about spread? Is that important? So let's take a step back and imagine two players in two leagues. All right, let's dive in here. The first league is a community center league. Here, the average points per game is 12, and the scorers have a standard deviation of 2 points per game. The other league, League B, is at the local YMCA. It also has a mean points per game of 12, but this data is more spread out with a standard deviation of 4 points per game. If we have a single player that plays in both leagues and he is going to see how he compares relative to the other players in both games. So this one player is playing in both games, in both leagues, and in both leagues he is averaging 16 points per game. Now in the first league, in League A, that puts him 4 points per game above the mean. And that puts him 2 standard deviations above the mean. Now we said previously 2 standard deviations above the mean is pretty good. That means that in the other league, he's only 1 standard deviation above the mean. He's still 4 points above the mean, but only 1 standard deviation above the mean. That's not as unusual. That means that in the first league, there's not very many players represented by this shaded area that are better than him in League A. But in League B, the shaded area is much greater. There's more players in League B that are better than this particular player. So because of that higher variability, there's more players who are playing and scoring more points per game than what he is scoring. So that's where z-scores come in. It takes into account the varied talent in each of the two leagues. So to find a z-score, we're going to be using this formula, taking into account both the mean and the standard deviation. So for this particular player, we take their points per game, we subtract out the mean, and we divide by the standard deviation and simplify, and that tells us the number of standard deviations above or below the mean. So again, we see here that he is scoring 2 standard deviations above the mean. So that's our general formula. Now, if we are working with a population, the x of I represents the individual score, the mu is the population mean, the sigma is the population standard deviation. If we were working with a sample, it's the same formula, except for we're using an x bar for the sample mean and an s for the sample standard deviation. Let's go back to are star basketball players and start with Wilt. So we're looking at Wilt, and we're now taking into account standard deviation, not just points per game. We're going to see if he still comes out on top. We're going to calculate their z-scores. So for Wilt, he is 30.1 points per game in a league where the average scoring that season was 13.6 points per game with a standard deviation of 5.27 points per game. Simplifying that gives us a whopping 3.13 standard deviations above the mean. That is significant. Remember, we said 2 standard deviations above the mean is really unusual. So this is unheard of. This is very good. So Wilt's points per game was 3.13 standard deviations above the mean for his era. That's very unusual. That is very good. Now let's move on to Jordan. 30.1 points per game during an era when the league was scoring 16 points per game, divided by the standard deviation at that time was 3.95 points per game. And simplifying that, wow, 3.57 standard deviations above the mean. That is even more unusual than what Wilt's z-score was. So even better than Wilt during his era. All right, that leaves LeBron. Let's see how LeBron is faring. What is his z-score? So we're plugging in his statistics against the league's statistics during his era, and he gets a z-score of 2.75. Again, very unusual. Remember, anything more than 2 standard deviations away from the mean is unusual, but still not quite as significant as something like 3 standard deviations above the mean. So not quite as impressive as Wilt and Jordan, but still quite unusual. So using these values, just this metric of points per game, it looks like Jordan emerges as our clear victor, scoring 3.57 standard deviations above the mean for his era, making him the most unusually high scorer. Now, how about a not so great player? Here's Adam. Adam plays for the LA Lakers. Here's him cheering on his team from the bench. Unfortunately, he only played 44 minutes during the 2009 season. Compare that to some of his teammates who played almost 3,000 minutes. And let's look at his z-score. See how he did. He scored an average of 2.2 points per game during an era when his teammates scored an average of 12.7 points per game with a standard deviation of 5.45 points per game. Let's find his z-score. Overall, he's going to end up with a z-score of negative 1.93. So you can end up with negative z-scores. That means he's scoring below the league average, not significantly below because it's not 2 standard deviations below, but still below the league average there. All right, so z-scores can be positive, they can be above the mean, they can be negative, they can be below the mean. That brings us to our discussion. So we have looked at z-scores. We have that Jordan has scored relatively more than Wilt and LeBron, and we have so far named him as the GOAT. But is that maybe because he shot and took more attempts than the other players? He sure did, maybe not by much, just outshot Wilt by a bit, took many more shots possibly than LeBron, and he did not make as many percent-wise as LeBron or Wilt. So maybe we should be taking that into consideration. Just some food for thought there. So here are your questions to consider. That raises some interesting questions for us. Some other metrics for you to think about. So, do you think Jordan should still be considered the greatest of all time? Why or why not? And what other statistics or data would you also want to see in helping to determine who is truly the best? Take a moment to jot down your initial thoughts to these questions, and we will discuss them further. That's it for today, statisticians. We will see you next time.